Okay, so for domain and range, have you heard these words before back in Algebra 1? Yeah, okay, so just kind of a review. So domain is going to be the set of all possible x values. So anywhere your graph is where there's an x value or where it could be. And then range is the set of all possible y values, okay? And you write these from the domain, you read them and you write them from the left to the right, just like you read a book or read words. And then range, when you're talking about that, you go from the bottom to the top. So domain is left to right, range is bottom to top. Okay, so then right here I have a picture of a graph. It's y equals x squared minus 3. It's this graph right here. So if I want to write what my domain is, what do you guys think? Does anyone have any thoughts what our domain could be? So if I think about this, so I have arrows on the end, so it can keep going up and it keeps going out, doesn't it? Like up and out, like it's gonna keep going in both directions. So could it go all the way to negative infinity? Could it keep going forever? What about on this side? Could it keep going to positive infinity? Yeah, so my domain is going to be, so the x values, it can go from negative infinity, even though it doesn't show that, but because there's an arrow, it could keep going. So it's going to go from negative infinity all the way to positive infinity. So the way I would write that is, I just write a D for domain. And then I'm going to use a parenthesis because a parenthesis is going to be when you don't include a value. So infinity, you can't ever actually touch infinity, so we use a parenthesis. We're going to use a square bracket if we include the value. But because you can't actually touch infinity or negative infinity, I would just write a parenthesis, negative infinity to positive infinity, and another parenthesis. Okay? All right, so now our range, this one I can just write an R for range. And then I want to go from bottom to top. So looking at this graph right here, can I have anything lower than this point?
No.
No, I can't. So the graph, it turns around and it keeps going back up, but it's never going to keep going down at all. Okay, so this is my lowest point. So where is that?
-3.
Yeah, -3. And how high up do you think the graph can go? Infinity, yeah, because these arrows say that it can keep going up. Okay, so my range, do I touch that -3? What do you guys think? I see some heads. You guys can talk or else I'll call on you. Ocean, what do you think? Do I touch -3?
Yeah.
Yeah, so since I touch it, I'm going to use a square bracket and I'm going to go from -3 up to infinity. I can't touch infinity, so I'm going to use a parenthesis. Okay? Questions on that first example? All right. So now there's a couple different ways to write the domain and range. My favorite, and the way I'll mostly write it, is just interval notation. And you can see it, it's written all of these different ways. It's just like we just did up here. You could also, if you want to explain everything in words, you could do that, but that's a lot more writing than just writing 2 numbers and parentheses. Or there is set notation, which would just be using like the greater than or the equal to or less than, all of that stuff. So you can write it any way you want, but like if you take more math classes, like as you go higher up, mostly everyone uses interval notation, okay? So that's what we'll kind of get used to. But in your book, you might see some of this, so it's good to know what both of them are, okay? So the set builder notation is just a verbal description of an inequality to describe the numbers. Interval notation represents the set of real numbers by the pair of values that are its left, our minimum, and our right, our maximum boundaries, okay? So if something like this, it just, your lowest to your highest, or your farthest left to your farthest right, okay? And then if I just kind of like read through some of these, so like say this example right here, so in interval notation it says it's negative infinity to 3. The 3 has a bracket, so I include it. So verbally what that says, it says all real numbers that are less than or equal to 3. So I can go from negative infinity all the way up to 3, and I'm going to include 3. And then in the set notation, I would have something like negative infinity is less than x, because I'm talking about my domain, which is less than or equal to 3. So the less than or equal to, because it's a square bracket, because I do include that point. And you don't need to write all this down. This is just some stuff I like kind of talk about, so. But yeah, so if you feel comfortable with one of the 3 ways, that's fine. You can pick your favorite way. I picked my favorite way. It doesn't have to be yours. So if you want to write everything in the set notation, that's totally fine. Okay, so looking at these graphs right here, we're going to write our domain and range for them. So I have this circle right here. So my domain, that's from my farthest left to my farthest right, right? So if somebody were to count this, let's see, Jade, what's my farthest left point gonna be?
4.
Yeah, so we have -1, -2, -3, -4, right? There's nothing farther left than -4. Haley, Winter, what's my farthest right point?
4.
Yeah, so if I were to write my domain, what would I write? Mackenzie, what do you think?
You put the parentheses and -4 and 4.
Okay. Do I want a parenthesis or do I actually touch there?
Oh, you want it.
Yeah, I'm gonna want a bracket, exactly. Yep, because I do actually touch right here at -4 and I touch at 4, so I do want a bracket. Okay, if we were to write it the other way, just because I don't want to push my favorite way on you guys, so if I were to write it like this, I could write -4 is less than or equal to, because it's a square bracket, and because I touch, so I have to have that equal to, x, which is less than or equal to 4. Both of those totally fine. Okay. All right, what about our range? Oops. Sorry guys, some of my, cool. Okay, so if I were to write my range, Paige, what do you think my bottom point is?
0.
0?
Or 70, sorry.
Oh, yeah.
-4.
Yep, -4. And then, let's see. Kaden, what's my top point?
Bottom 4.
Okay, so then what would I write for my range, Kaden?
Negative, bracket, -4, and then positive 4.
Yeah, exactly. So this one's actually the same as that one. If I were writing my range like this, I would write -4 is less than or equal to, and then this time instead of x, I would write y, because I am talking about my y values. So y, which is less than or equal to 4. Okay, so either one. All right. So now for the other one, we need to write our domain and our range. So Braden, what do you think my domain for this one is?
Parentheses, negative infinity, infinity.
Yeah, parentheses, negative infinity to infinity. So it's hard to tell because, I mean, really you could count out -1, -2, -3, -4, but it has the arrow, so it keeps going out. So it keeps going up and it keeps going out. So you have to always think, even though it doesn't look that wide, it really eventually is gonna hit like negative infinity and infinity. Okay, and then let's see. Haley Burry, what do you think my range is gonna be?
Well, if there's nothing, just be 0.
Okay, so, yep, my lowest point would just be 0, right? And then what would my highest point be? Yeah, exactly. So what would I write?
0, or bracket 0, infinity.
Cool, exactly. Okay. Are you guys good with this? Cool, awesome. Okay, so then finding our x and our y intercepts. So we have just this problem right here. So it says a car starts a journey with a full tank of gas. So we have a word problem. The equation of our line is y equals 16 minus 0.5x, and it relates the number of gallons of gas, which is our y, left in the tank, and the number of miles the car has driven. Which makes sense, because if you fill up, you haven't driven at all, you have a full tank, as you start driving, your gas is gonna go down. We all understand how that works. Okay, so I wanna figure out what my x and my y intercepts are from my graph. And then we wanna figure out what they represent. So like, since this is a word problem, like what it represents. Okay, so what do you guys think? What's my x-intercept gonna be? If you look at this graph right here, where do I hit the x-axis? Kaden?
320.
Yeah, 320, okay. So, because we always write everything as coordinates, my x-intercept, if I write it as a coordinate, would be what? Braden, what do you think? Derivative it.
X 5.
What about 320 is my x, right? We just said that that's where my x-intercept is. What's my y right there?
0.
Yeah, 0. Cool. Yep, so that's my x-intercept. Okay, so everything's always coordinates. All right, what about my y-intercept? Cooper, what do you think for this one?
16, 0.
Yeah, well, would it be,
16.
yep, 0, 16. Yep, because my x is 0 and my y is 16. Okay, and so then in terms of like what they represent about the situation, if my x-intercept is at 320, what do you think that means in terms of like my car and my gas and everything like that? Kelly, what do you think?
Like your total distance to your lines.
Yeah, exactly. I can drive 320 miles, and if I don't fill up by then, I'm gonna be out of gas sitting on the side of the road, right? I can drive 320 miles. And then what do I think the y-intercept tells me? The 16. Paige, what do you think about that?
That's, how much gas you're
Yeah.
gonna gallons, I don't know.
Yeah, exactly. Like I can put 16 gallons of gas in my car to start off with. Okay, cool. So word problems, understanding like what things mean. Okay, so let's go ahead, let's find our x and y intercepts. And this time we have an absolute value. So it says y equals the absolute value of x minus 3. Okay, so if I were to graph this, do you guys know off the top of your head what an absolute value graph looks like? I know you did geometry last year, so if you don't remember everything from Algebra 1, that's fine. No? What about like a V? Does anyone remember that? Like absolute value looks like a V? No? Did you not do much with absolute value? Okay, well, we'll graph it in our graphing calculator then, so that we can take a look at it. So I'll teach you how to put absolute value in your graphing calculator. Okay, so we're graphing, so what you need to do, if you go to your y equals, if you have stuff in there, just clear it out. And now, because we need the absolute value signs, if you hit math, which is under second and alpha, and then if you go over to number, so if you use your arrow key, go over to number, and then it says abs with a parenthesis, go ahead and just hit
High
enter on that.
schoolers, if you parked in front of the Methodist Church dumpsters, please come to the high school office. If you parked in front of the Methodist Church dumpsters, please come to the high school office.
Okay, so we have, did everybody find that absolute value button? Yeah, so then go ahead, once you hit enter, it should be in your y equals, and then you can put x in the middle there. And then use your arrow key to get out of your absolute value and then hit -3. And then you can go ahead and just graph it. And I'm just gonna make sure everybody's seeing that. So if we do a y intercept, so then 3 next to that, cause it's all one equation. Yep, exactly. Yep. So anytime we're trying to graph, you wanna use your y equals so that it'll graph it. So you just pronounce this whole equation. And then go over the Oh, pronounce it. Use your arrow key out and then minus Awesome. And then we'll all get more comfortable with these, so don't worry. Oh, I can't see this X. I have vision. This X we don't need, so we can go here. So if we go to our y equals first, and then we can delete that other equation out, we can just clear it. And now you can go to math. And then number, yep, and then absolute value, and then x, which is that one. Yep. Yep, and then you can graph, so that you can actually see the graph. Did you, oh, I think you used the negative instead of minus. So we can just change it, so -3. Cool.
Thank you.
You're welcome. Okay, is everybody good? You use negative, so you gotta use, so, gotta use minus instead of negative, just depending on what it's doing, because it does change your graph. Okay, does everybody see a V that's opening up, that's kind of shifted down 3? Let's see. Okay, so we're in, so anytime you want to graph, you're gonna go to your y equals, so we can type it in, so we're there. Now use math, then over the number, then absolute value, and now we can use x. Oh, did you use that? Did you use your alpha? Okay, so this button right here, with the way that is just your x right here. So that's what, so that's just like the variable button. Yep, exactly. Yeah. Got that. There's your graph. Awesome. Okay, don't worry guys, we'll get way better at this. Okay, so now we see an absolute value graph. And the -3, we can see that it shifted down 3. So here it is, and it's a V like this, right? Keeps going, something like that. Okay, so I wanna go ahead and find my x-intercepts. But the x-intercepts, you're also gonna see them called the zeros of the function. And the reason that they're called that is if you look right here, when we're talking about our x-intercepts, isn't our y always 0 on an x-intercept because it's not moved up or down at all? So if you see something and it says find the zeros, that means find the x-intercepts, okay? So they're the same exact thing. So zeros, x-intercepts, same thing. And the reason, yeah, so because the input values are the result of a function when the output value is 0, which basically just means that your y is 0. Okay, so if I need to find my x-intercepts of this, if you look on your graph, where does it look like my x-intercepts are? 3. How would I write that?
-3 and +3.
Okay, but I always want to write some coordinates, so,
Aren't those coordinates?
well, -3, +3, like -3, +3b over here, like -3, positive, wouldn't that be right there?
3, 0.
3, 0, okay, I like that. And the other one?
-3, 0.
Exactly, okay? So it's different than writing domain and range. So your x-intercepts and your y-intercepts, you have to write them as ordered pairs as coordinates. If you tell me -3 to 3, that's technically like this point right here. That's not our x-intercept, okay? All right, and so even just with eyeballing, I wanna show you some other things on the calculator. So if you go second in that graph button, we should see a table. And this is also a good way to find your x-intercepts, or we could solve it, but we're not gonna solve today, we'll do some other stuff. But if you look at your table, you should see when your x is -3, that your y is 0. And then if you go use your arrow key to go down, you should see when your x is 3, your y is 0. Is everyone able to see a table? Some of you have it set up that you're graphing table, you can see at the same time, which is totally fine. So let's put our equation back in, so that, over the number, and then x. And then you should, if you see your table at the same time, if you didn't have that, you would do second for that. Yeah. Everyone's. So yeah, so that's another way, because sometimes just eyeballing stuff off the graph, that's not always super accurate, so it's nice to use our table. Okay? Alright, let's go ahead, let's do the other one, let's find our x-intercepts of 4 minus x squared. Okay, let's go ahead, let's practice in our graphing calculators. So if you go back to your y equals, because anytime we're trying to graph, we need to go to y equals. You can clear out that other equation because we don't want both of them at the same time. We're just dealing with this right now, so go ahead and type in 4 minus x squared, and then you can graph that. So we go back to our y equals, and then we can clear it out and put in the equation. And everybody should be looking at a parabola upside down, like an upside down view. Is anyone, Braden's not seeing that?
I'm looking at a straight line.
4 minus x, did you use the minus? Did you use this x? Which, oh, you use like the letters? Okay, so you always have to use this one right here, because this is like the variable. This is, yeah. Type it in again. Alright, everyone else is okay? Oh, this is going in next. Yeah. Alright, so I think everyone's got it. So you guys should be looking at a graph. It goes up 4, and then it kind of comes down. Something like this, okay? So we need to figure out where our x-intercepts and our y-intercepts are. Oh, sorry, I skipped on this one. Where's our y-intercept on this one? Kid?
0, -3.
Yeah, 0, -3. Sorry. Okay, so that's where our y-intercept is. Okay, so now over on this example, my x-intercept, where do I think that's gonna be? Ocean, what do you think?
4.
4. For my x ones?
Oh, I don't know.
So if we look at our graph, or if we look at our table, we should be able to tell.
Is that 3 over?
Look at your table to see if.
Oh,
wait,
4. Right? Or what am I supposed to be looking at?
So you're looking for when your y is 0. So,
So, it'd be 2.
Yep.
Oh,
And then-
alright. I see it now. My
Yep.
bad.
No, you're good. So we have 1 at 2, 0. And we can tell, just by kind of looking at the lines on the graph, or by looking at our table, because I'm always looking for where my 0 is in the y spot, okay? Because that means it's gonna be an x-intercept. It's not moved up or down at all. So I have 1 at 2, 0. And then, Mia, where do you think this one might be? 0, 3. Okay. For our x-intercept?
Oh, 0, -1. Wait,
Super close.
0, -3.
Try -2. If you look at your table,
So we're looking. So, okay, so when we're looking for when our y is 0, so we have -2.
Yep.
So, and then -2, we also have 0, so,
So you're looking for when your y is 0, okay? I know it's kind of confusing, you might be looking where your x is 0. So we'd have at -2, 0. Okay, what about our y-intercept? Cooper, what do you think?
0, 4.
Yeah, 0, 4. Yep, because that's just gonna be this point up here. Okay, questions?
How do you get the table?
So if you hit second and then you hit graph, gives you your table. Okay? Alright, cool. Alright, so now positive and negative. So the positive and negative intervals, the positive part of the graph is just gonna be the area above the x-axis, or basically where our y-axis is positive. So all of this would be positive. So everything that's up in the positive y. Okay, so anything above the x-axis is positive, anything below the x-axis is negative, which makes sense if you think like down here you'd have like the negatives on your y, and up here you have the positives on your y. So positive above x-axis, negative below the x-axis. And the way that we write these is gonna be similar to our domain and range. We're gonna write from like one number to another number, and we can just use parentheses. We don't have to use brackets, only come into play with domain and range, okay? So we'll have positive and negative, and then we'll do increasing and decreasing. But for those, when we're talking about a range of numbers, we just use parentheses, okay? Alright, so looking at this right here, it says where is the function positive and where is it negative? So I have this graph right here. So it's gonna be positive when it's above the x-axis. So this piece right here is positive, and this piece over here is positive. So I have two different positive pieces. So the way that I wanna write this, I can write, so it's positive from, well, because I have this arrow, I know that it can keep going up and out, so, and I'm talking about it like it's a domain. So I'm talking from like left to right, okay? So everything that we do for the rest of this section is you're talking about your x values, so you're thinking about them like domain. Range is the only time you use your y's, okay? So my x's, it can keep coming up and out, so I can go from negative infinity to when my x is -3. Okay, all of this would be positive up here. Does everyone see that? Yeah, so I could write negative infinity to -3. And the reason that I'm just gonna use parentheses, because right here at -3, isn't it really not positive and it's not negative, it's just right on the line? So it's not included in positive and it's not included in negative, okay? So I go, all of this area up here is positive. Now this stuff down here, this is gonna be negative, right? Because it's below my x-axis. Okay, so if I'm gonna write my negative stuff, I'm going from when my x is -3 all the way over to when my x is 3, okay? So I'm not talking about it in terms of y, not like 0 to -9. I'm talking about it in terms of x. So when my x is -3 to my x is +3, okay? So my negative would be -3 to 3. Does everyone see that? And then my positive, again, I have another positive piece, this stuff up here, would be from 3 up to, it can keep going up and out, so 3 to infinity, okay? Everyone okay with that? Okay, and then the other question, it says, where is it neither positive or negative? Where do you think it isn't positive or negative? Are there any points on the graph that it might not be? Kaden?
At the intersection.
Yeah, exactly, at the intercept. So these right here, when our x is -3, our y is 0. So it's not a positive number and it's not a negative number, 0 is just 0. So these right here would be neither positive nor negative, which is why I use the parentheses, because I'm not including it in a positive number or including it in a negative, okay? Because it's just neither. Okay. Okay, so let's go ahead, let's do another one with positive and negative. But let's go ahead, let's just type it in our graphing calculator. And then we can look at it and then determine where it's gonna be positive and negative. Okay, so I have the equation y equals 2x plus 10. Does anyone think they know what this looks like before they even graph it in their graphing calculator? Kaden, what do you think it looks like?
Straight line like
Straight line like that. Where's my y-intercept gonna be?
that. 10,
Yeah. And what's my slope?
2.
Exactly. Okay, so y-intercept, and it's gonna be like a slope of 2, something like that. Okay, so is anybody struggling to type this in? So 2x plus 10. Okay. So, with my 2x plus 10, where do you guys think that this graph is positive? Like, talking about my picture up here, is it gonna be the stuff down here or the stuff up here?
There.
Yeah, the stuff up there, because positive is everything above my x-axis. Negative is everything below. So, it's gonna be positive. First of all, let's go ahead and figure out what's this point right here. Where is my x-intercept?
5.
5. Positive 5?
-5.
Negative 5. Yeah, so this right here, my x-intercept is at -5. So that helps me because remember I'm always using my x values. So what would my positive interval be? Does anyone have an idea? Jade, what do you think? So we know it's this stuff up here, right? And so it starts right here, doesn't it? So what's my number right there? And then how high could I go? Yeah, exactly. So how would I write it? Other way around. So I always think about it like I read left to right. So I want to go left to right. Okay? So I'd go -5 to infinity. And I want to use parentheses for both because I always use parentheses for positive and negative. All right. What about for my negative? Haley Winter, what do you think? So if I'm thinking about it, so this can keep coming down and out, right? So if I'm talking about it in terms of x, so can it go all the way to negative infinity? And then where would it stop? Exactly, so what would I write? Exactly. Yep, just like that. Okay? And then where do you guys think that this is so we figured positive, negative, but where is it neither at? Cooper, what do you think? -5 and 10. So right here it's positive, isn't it? Because it's above my x-axis. So it would just be the -5. So it's neither at this x-intercept, because x-intercepts aren't positive and they're not negative, they're neither. So it would be neither at -5, 0. Okay, so neither at your x-intercept, okay? All right, so then the last kind of new idea is increasing and decreasing. So increasing is when the slope of the line is positive Decreasing is when the slope of the line is negative. So increasing when the graph is going up, decreasing when it's going down, okay? So I know there's all these new words. So remember, positive is above the x-axis, negative is below, increasing, going up, decreasing, going down. Okay, so those are the 4 things you kind of got to remember. So we have the graph right here of 2 minus the absolute value of x, and we need to figure out where it's increasing and where it's decreasing. Okay, so looking at this right here, do you think it's increasing over here or over here? The left side or the right side? What do you guys think? The left, yeah, because my slope is positive, my line is going up. This is increasing. This right here would be decreasing. Okay, what about in terms of positive and negative? This stuff right here, is this positive or is it negative? Just from here down. Positive or negative? What do you guys think? If I'm below the x-axis, negative. Okay, what about this stuff up here? Positive or negative? Yep, and then this stuff over here, positive or negative? Cool, yeah, exactly, okay. All right, so in terms of increasing and decreasing, I also write it just like I wrote positive and negative, I just use parentheses. I write it in terms of x, okay? So you look at where your x value to your x value, you don't use your y's. The only time you use your y's is your range, okay? So it's increasing so we just said it's increasing on this side over here. So in terms of my x values, it can keep coming all the way to negative infinity. And then it's gonna stop increasing, not at 2, I'm not talking about my y, I'm talking about 0 because I'm talking about my x, okay? So it will be increasing from negative infinity to 0, okay? So I would write it just like negative infinity to 0. And then it's decreasing from my x when my x is 0, all the way I keep coming, it's decreasing to negative or to positive infinity. So I'd go from 0 to positive infinity. Okay. So remember, increasing, going up, you use your x values. So your x is negative infinity all the way to when your x is 0, and then decreasing when your x is 0 to positive infinity. Okay? Questions? Okay, let's go ahead and let's do some other ones. We'll type them in the graphing calculator. So it says, what are the intervals in terms of x where the function is increasing and where it's decreasing? So go ahead and type in the first one. Just type in y equals x squared minus 4x. And then make sure you're using the minus, not the negative button. Does everyone see a U? Yeah. Okay. So the graph of this one, where does it look like my x-intercepts are? Faith, what do you think? Where are my x-intercepts on that graph? Do you,
I'm still checking.
are you still typing it in? Yep, that's right.
So, looks like we have one end.
Yep, exactly. Where does it look like that other one might be? If you count those tiny ones. Or look at your table. Exactly. So Faith just told us we have x-intercepts at 0 and 4. Okay. I And then where does it look like it kind of turns around on the bottom? So we're trying to graph this as accurate as possible. Does it kind of look like it's at like 2.4? Is anyone else seeing that? Or 2 - 4, sorry. Yeah, so if I come over to 2 and -4, there I have some points, okay? So then I have a graph like that. Okay. Everyone seeing that on your graphing calculator? Yeah. Okay, so we need to figure out where it's increasing and where it's decreasing. Is this stuff right here, is it gonna be increasing or decreasing? What do you guys think? Decreasing, exactly. So now I need to write the interval. But we'll start there tomorrow, okay? So we're almost done, guys. This was like the last slide, so we'll finish that before the activity tomorrow, okay?